files, and input output, protection, and the shell. So these are the topics available in the under this concept, various concepts of operating system. Now we will see what is the address spaces. Yeah, these address spaces, files, input output, protection, the shell. So these are the concepts. These are the concepts available under the name of various concepts of operating systems. Okay. Now process we have discussed. Process we have discussed in the first class. Now we will see this life cycle we have discussed. Process contains these stages. This we have discussed. Then we will see the next one, the address spaces. This is address spaces. You see the address space is an abstraction of physical memory. So what is a memory means? A memory which contains is a memory which contains data. Data, anything, any kind of data. This is the data, this is the data, this is the data. So memory which contains the data. So here address space is the abstraction of physical memory. That means physical memory is real, then abstraction of physical memory is virtual. Okay, now see this. The address space contains all memory states. So what are the states here? Code, stack, and heap. These are the three components the address space contains. Now example, this is a memory. This is a memory. This memory, this is a code. This is a code. And the next one is, this is the stack. And let us take, this is heap. So this is the memory states. These are memory states. Okay. So here, the code. First one is what? Code. Now see what is the code here. You see the diagram. If you see this diagram, see here. This is the code. What I said now, this is the code. Okay. Now this is a stack. Okay. Now this is the heap. Three components inside the memory. Now this is complete is memory. This is memory. This is memory. inside this memory, we said there is a code, program code. We can say program code in the heap, then in the stack. Now what is this is the free memory. This the memory is free. Okay. Now these memories are having the size. You see this program code is 0 to 1 KB. This is the size. Now heap is presently what? 2 KB. Now stack is how much? 16 KB. This is. Now how much free space is having? This is a free space. 15 KB is the free space. Okay. Now we'll discuss step by step now. See. Now, first one code. See code what is doing? This code, it is reside means it is inside the memory. Okay, inside this memory. So it stores instructions related to the program. So I said this is a memory. Inside this memory, this is a code. So this is the code. Now inside this code, what are there? Instructions are there. These are instructions. Okay. These are instructions which are related to this code. So that is the first one inside the memory. The next one is stack. You see the stack. So stack is somewhere else here. This is stack. This is a stack. Now what is inside the stack is, see, the stack, it keeps track of where the code is during its calls. Now this stack, what it is doing, it is tracking. Now this code is belongs to where? This code belongs to where this stack is tracking. So it also allocates local variables and passes and return values from the function. So this stack allocates what? This stack allocates memory to local variables. Inside this stack, these variables are there. Be clear. This is the memory. Inside this memory, this is the stack. Now inside this stack keeps tracking where the code is during its call. This is the code. This is the code during its calls. Here calls means these are the calls. MLOP and free. These are the two calls. Calls means you can understand methods. Okay. During the methods, method call, you can say during this method calls. Example I given MLOP and free. So during this method calls. So the program, the stack, this is stack, this block keep tracks of where the code is during its calls. That is, this stack is tracking this code. Okay, and this stack is also allocating the local variables. So also allocating the variables and returns values from the function. Now through these functions, it is returning the values. Okay, through these functions, it is returning the values. So this task return values. Next one is what? Heap. Now this is dynamically allocating. This heap is what? Dynamically allocating and managing user memory. So example is what? These are the example calls. These two methods are example calls for the heap memory. Next one, the size of the address space is determined with a unique address. Unique address means example you can take. Say this is 1, 2, 3, 4. it is one unique address. Let us take 2356. It's one unique address. So this address is different and this address is different. So like that, it will the size of the address space is identified with the unique address. And this address will be calculated generally according to the system's bit size. Where bit means here you can take 32 bit and 64 bit. Okay, 32 bit and 64 bit. And if it is 32 bit example, then the operating system has 2 power 32 unique memory addresses. If it is 64, if it is 64, that is 2 power 64 unique memory address available. So this is the address space means here. Now see this diagram. Now from this diagram, see the diagram shows what 1 KB is filled with the code data. Now what is this one? This is 1 KB. This is 1 KB. And this is static and easy to place in the memory. Okay. Next one, it divides the remaining address space into two portions. So that is, these are the remaining, that is remaining address means this one. Two portions it is dividing, that is one is heap, then one is stack. So here see, that portions can increase and decrease in size. Now this heap can be increased or decreased. This stack can be increased or decreased. Example, your stack is 16 KB. If you want to increase up to 18 KB, now this extra 2 KB, you can take it from this free space. So that is increase. And if you want to decrease, you can give the space to the free space. Okay. This is increase, we can decrease. You see here, the first our heap which will place after our code in the stack, which place at the end. So first one is code. This is second one is a heap. Then the third one is stack. Now this heap also increases when user requests more memory. What I said, this one. Now presently heap is how much? 2 KBs. If any user wants more memory, this heap size can be example 2 KB to 20K. 2 KB to 20K. That can be increased to 2 KB to 20K. So that is the meaning of this line. So the heap size can be increased upon this user request. Okay. While the stack also can be increased when user makes any procedure call. Now this stack size also can be increased when any user, this is the user, if any user makes a procedure, okay, some kind of calling. So some based on that, the stack memory can be increased. That's a 16 KB it is, right? Now it can be increased. So this is what address space means. So next one is files, input output protection, the shell. Now we will see them. Here, files. These are the files. concept. Now, see, file concept is this again one more key concept supported by virtually all operating systems in the file system. So this concept is supported by all operating systems. So system calls are obviously needed to create the files. So if you want, we will create the files like this. This is a file. Then file content is a file name. Is a file name. Okay. And a file can be created. Okay. It can be removed. Okay. And it can be read files, then write file. So before a file can be read, it must be located on the disk. See, if any file, if we want to read, these are the operations. Let us take read. Okay. We'll see. Yeah. Read. The file can be read. So when it wants to read, it has to be in the memory. It has to be in the memory. So that is to be in the memory. Now see, uh, now before a file can be read, it must be located on the disk. So that means it must be inside the memory. And after it has been read, it should be closed. So so any file, any file after reading, we have to we have to close. So we have to close. Now example, this is a file. This file we read, and after that we have to close this file. We have to close this file. So that is the meaning of file concept here. So to provide a place, so any file, this is a file. So we need to provide a place. Place means what? We have to give memory. For this file, we have to give memory. We have to give memory. So most operating systems have the concept of directory. Okay, one more concept is what? Directory. Let's take, this is a file. So this is a file. Now this file contains inside the directory. Now this is a directory. Okay, this is the directory. This inside this directory there is a file. So see here, uh, most operating systems have the concept of directory as a way of grouping files together. So that means a directory can hold one or more files. This is one file. Okay, like this, one more file, two, like this, one more file, three. So all these files are inside this directory. So that is the meaning of this statement. So most operating system, what they are doing, they are they have the concept called directory, and the directory can hold files, not only one file, that can hold one or more files, one or more files. Next one, see here, hierarchy, you see this. Now this is the directory. Okay, the one directory contain one, these are subdirectories, and the directories contains remaining all files, these files. Next one, input and output. Input and output. Here, all computers have the physical devices for acquiring input and producing the output. So any computer you take, that the computer contains physical devices. This is physical devices. Physical devices means which are which we can touch and feel. So those kind of devices are called physical devices. So these physical devices have the input. That means they have the input physical device, then they have the output physical devices. The input physical devices give the input. The output physical devices display the output. So that is the input output means here. Many kinds of input and output devices are there. So not only one device, there are so many input devices and so many output devices are there. Example here is keyboards, monitor, printers, examples. These are the physical devices. These are the physical devices. That means we can, these devices we can touch and feel. So like that. So it is up to operating system. It is up to the operating system to manage these devices. Okay, that means these all devices are, these physical devices are under the control of operating system. So that is input and output. So every operating system has an IO. IO stands for input and output. Subsystem for managing IO devices. So this is also called, that means these physical devices are also called IO devices. IO devices means input output devices. So this is one system, IO system. This is called IO system. So to manage this IO system, so there is a IO device. To manage the IO system, there is IO devices are there. So IO devices are what? Physical devices. So that is the meaning of this. Now some of the IO software is device independent. Okay. So according to the device, the software exists. So all devices cannot contain same kind of software. So it applies to many IO devices equally. So this is the meaning of input and output. So this is one of the component. Next one, protection. Protection means it's a computer contain large amount of information. A computer contains large amount of information that users often want to protect and keep confidential data. So this is a computer. That computer contains large amount of information. This information is inside the file. This is a file. Now these files are inside the directory. This is the directory. This is the file. So what is protection we are giving? We are giving protections to our files. The files contains what? Data. The files contains data. So that data we are calling as what? Information. So this information to be protected, to be protected. So it is up to the operating system, this operating system, to manage the system security. So whose job is to protect this information? The job is operating system job. This is the operating system to protect this information. This is the operating system. This operating system, what is job it is? It has to protect this information. Okay. So example is what? Only accessible to authorized users. That means if anyone want to access this information, they have to prove their identity. They have to prove their identity. Example is what? Example is their username and password or any PIN number. Okay. These kinds of these kinds of data is called, these kinds of data is called, means it is authored to prove the identity. This kinds of data is, sorry, this kinds of data is provided to, uh, provided for authorization. Authorization. So there are so many ways are there to prove the authentication. So this is the protection. Next one, the shell. Next one is what? The shell. So these are all components under the, these are operating system components. Various components of the operating system. These are all. The last one is the shell. This operating system is a code that carries out the system calls. The system calls means they are nothing but I can say methods. Methods. Okay. Example methods we have seen just before. Free is one method. Okay. Open is one method. Close is one method. These are also called. These are also called system calls. System calls. Okay. So that is system calls. Editors, compilers, assemblers, linkers, and the command interpreters. So these are not part of the operating system. Okay, these are not part of the operating system. Okay, so the command interpreter called the shell, although it's not part of the operating system. So that is, it makes heavy use of many operating system features. Okay, that is the servers serves is a good example of the system calls can be used. So when any user logs in, the shell is started up. The shell has a terminal as a standard input and standard output. So many personal computers have GUI. GUI means here GUI, graphical user interface. GUI. That means you can work with, you can communicate, communicate with uh, any physical devices, any physical devices. Okay. So that is the GUI. So these are the various components of the operating system. So these are the various components of the operating system. So first one is process, then address spaces, files, input output, protection, the shell. These are the six concepts of operating systems. We will see. Next one will see functions. Next is the main functions of an operating system. Okay. See here, there are so many functions are there. We are discussing very so many important functions here. So one function is it is an interface between user and hardware. One of the main important function of the operating system is it is an interface between user and hardware. See, this is the hardware. This is the hardware. Okay. This is the user. Okay. Now in this middle operating system is there. Now this is taking instruction from the user. It is giving to hardware. Okay. Then taking the hardware given output and giving to user. So that is the meaning of interface. It is then who is interface here? Operating system is an interface between user and hardware devices. So that is one function. Next, what next functionality of the operating system is what? Allocation of the resources. There are so many resources are there. So this the operating system job is it has to allocate the task to hardware components. Which hardware component has to perform what kind of task? It is that resource is allocated by the operating system. That is one job. Next one is management of memory security. So how much memory this user input is required? Okay. How to take care of the user data, that is security, how to give security. So these are the functionality to taken care by the operating system. So next one is what? Convenience. So operating system makes computer more convenient to use. So we can easily communicate with the computer. We can easily communicate with the computer. So no commands required. We can use computer very conveniently. That is one. Next one, efficiency. Operating system allows the computer system resources to be used in any efficient manner. Okay. So they work in a very efficient way without, maximum it doesn't make any mistakes. So that is called efficiency with a 0.01 error. It gives the accuracy. So that is the 99% it is accurate. That is the efficiency. Now, ability to evolve. One more functionality is what? Ability to evolve. See, first functionality what? It is an interface between user and hardware. Next one, it allocates the resources. Resources means your hardware components job, they have to handle the user information. Next one, management of the memory, security, etc. The operating system handle the memory. Memory means every computer contains, this is a computer, every computer contains memory. Inside this memory, the data is there. Okay. For this data, how much space is required? How much space is required? It is taken care by the operating system, and the security also taken care by the operating system. So that is the management of memory and security. Ability to evolve, that is an operating system should be constructed in such a way as to permit the effective development. Okay. And testing and introduction of the new system functions without the same time interfering with the service. So it is uh, it is having the very effective development. Is having the effective development. The next one is what is user interface? So we have discussed this is the sentence we given user interface. That is operating system. The shortcut name is OS. The operating system provides the convenient interface to programmer for using this system. So we have discussed this elaborately. So that is the user interface. So these are the list of functions of the operating systems. The next one is next concept is types of operating system. We have discussed three concepts. One is components. Second one is functions. Next, third one is types. Types of operating systems. So there are types there. So these are the types: real-time operating system and a single user, single tasking. We can say single user or we can say single tasking operating system. Then you can say single user and multitasking operating system. That is a multi-user, multitasking, and multi-programming and batch operating. So these are the types of operating systems. We will see one by one. The batch processing, see, batch processing. The first operating system is a batch processing operating system. Now see here, these are the jobs. This job one, okay, and job two, job three, job four, and job five. These are the tasks. You can say called task and say jobs. Now what this computer did, these jobs are, the jobs are uh, combined. The jobs are combined as a batch. You see here, this batch one and batch two. So in the batch one, they sent two jobs. The batch two, they sent three jobs. You can call jobs, you can call tasks. So these jobs are with these two batches are given to computer. These two batches are given to computer. Who is given these jobs? These jobs are given by the user, you can say operator or the user. Okay. See, yeah, there are so many jobs are here. The jobs are there. So not only five jobs, there are so many jobs are there. These jobs are collectively combined according to the batches. So batch one, batch two, then similarly you can say batch three, so on, so many. So yeah, it consists, the similar jobs are grouped together for processing. So the batch one contain similar type of jobs. The batch two contain similar type of jobs. That means batch two, three, five contain similar kind of task. The batch one and four, they carry similar kind of task. So as they are similar kinds, means same type of jobs, they grouped into batch wise. So that is the meaning of L. The similar kind of jobs are grouped together for processing. Okay. Now it consists of programs, data, and system commands. So what the jobs consist, they may consist of programs, then data, and commands. So the time taken between job submission and job completion it is very high. Okay. To complete this job and to complete this batch job, it time is they take more time. They take more time. So it is suitable for programs with large computation time where users involvement is not necessary. Okay, it is suitable for large computation, not for small computation. So computation here means some kind of calculations. So that is batch processing. This is a batch processing. And this is what batch OS, batch operating system. Next one is multi-programming. You can see multi-programming, multi-programming operating system. So what is a multi-program operating system is, so the memory consists of jobs waiting for the CPU time. Now this is CPU, this is the CPU. These are job one. Job we are denoting with J, job one. This is job two. This is job three. Okay. This is the CPU. Okay. So what is doing? The main memory consists of job waiting for the CPU time. So where are all the jobs are? The jobs are inside the memory. Inside the memory. Okay. Now in this memory, they are waiting for the CPU time. The job is waiting for the CPU time. The job is waiting for the CPU time. Likewise. Then operating system selects one of the processes and assign it to the CPU. So what the operating system do now? The operating system do, it takes one job. Okay, it takes one job and give it to the CPU. Then after that, it takes one more job, then give it to the CPU. Here. This is multi-programming. Here see these job A, job B. Now these are all there. These jobs are in the memory. Okay, in the memory. These jobs. Now these jobs waiting for what? CPU timing. This is the CPU. The job is waiting for CPU time. Okay. Now who is allocating this? This operating system is giving the job to CPU. Okay. Now see here, two or more programs are executed simultaneously by single processor. Okay. It is used in a multi-user environment. Here, one CPU is there. See once. Now see. So the operating system selects one of the processes, assign it to the CPU. The operating system, it selects job one. Okay, job one. It selects job one and give it to the CPU. This is the CPU. Okay. So whenever the executing process needs to wait for any other operations, okay, then operating system selects another process from the job queue. Now suppose this is in the waiting state, then immediately what the operating system do? Immediately it selects the second job and it give it to the CPU. So it is not wait for the first job. So let the first job is waiting time, waiting list. Then operating system select the second job and give it to the CPU. Okay. So that is now this way the CPU never keep idle. Okay, the user gets the then multiple tasks done at once. So this CPU can never wait for any kind of job. Okay, if the job one is waiting, then it will select job two. So how it will select? In the middle, operating system is there. So operating system is giving to the CPU. So if the job one is waiting, it will select the job two and give it to the CPU. If job two is waiting, it will select the job three and give it to the CPU. So this is called multi-programming. So nowhere the CPU is not idle. It is not idle. It is not free. So every time it will perform any one of the job. So this is called multi-programming operating system. Next one, multitasking operating system. Multitasking. Yeah, multitasking operating system. Multitasking operating system combines the benefits of multi-programming operating system and CPU scheduling to perform quick switches between the jobs. So here the switch is a user can interact with each program as it runs. So this is multitasking. So we will understand with one diagram. See here, this is multitasking. See, the user is switching between these applications. See, the user opened task one, right? Then user opened Excel, then user opened browser. These three tasks, so the user is opened. So even though they are opened all same time, the operating system is giving the facility the user can switch between these three applications as they require. If they want, they can do task with Word. If they want, they can do task with the browser. If they want, they can do task with Excel. So this is the multitasking environment. The user have a choice. They can user can switch between very quickly, switch between these three applications. So this kind of nature is having the multitasking operating system. Okay. The next one is a time sharing. The time sharing operating system is that. Now what it's doing? See, there are so many users are connected. User one connected, user two connected, user three connected. Likewise, so many users are connected to CPU. So what the CPU see here? In this, the processor is shared among many users. Okay, the CPU switches so rapidly from one user to another that every user gets the impression of getting the service of the CPU for all the time. So what the CPU is doing, every user it is giving the service. See here. So user will not feel that he is in waiting state. Okay, the user can never be in waiting state. The user job can never be in waiting state. So CPU handling according to the time. So this is called time sharing operating system. So that's all about the types of operating system. Okay. That's all about the types of operating system.